So we are asked to find the limit in this problem of 1 plus k, where k is a constant, over n to the power n when n goes to infinity. So of course this is a beautiful example where um, the first approach will be to say, okay, 1 plus k over n to the power n. This goes to 1 plus 0, because k is a constant, therefore 1 over n goes to 0, to the power infinity, which is 1 to the power infinity. But the problem is that 1 to the power infinity is an indeterminate form, and therefore we don't know what's this. So the problem here is still not clear. Don't say that 1 to the power infinity is 1. That's not true. Okay, so this is one of the indeterminate forms. We don't know what it is. So here, how do we do that? One way is to go to the exponential log. So we know that a to the power b is equal to e b ln of a. So that's the formula we're going to be using here. So we know that 1 plus k over n to the power n is going to be e n ln of 1 plus k over n. So now the focus will be only on the exponents. Okay, whatever limit we find, the answer will be e to the power of that limit, and we are done. So here, the focus now we said will be on n ln of 1 plus k2 over n. So what's the limit when n goes to infinity? So n goes to infinity time ln of 1 plus 0. ln of 1 plus 0 is 0. Therefore, we have infinity times 0. And that's also an indeterminate form. It's not 0. It's an indeterminate form. So one way to solve this is either to bring the infinity down, it becomes 0 over 0. To bring 0 down, it becomes infinity over infinity, and use Hopital rule. So here we have a choice. Either we bring down n or ln. If we bring ln, it becomes very complicated, 1 over ln, so we're going to bring n. So this becomes ln of 1 plus k over n over 1 over n. So you see now the top goes to 0, ln of 1 basically is 0, and the bottom goes to 0, so we can use now Hopital rule. So all this work was done. So either you use the symbolically Hopital rule with n, but be careful, this is a sequence, so it's not differentiable, or you can take the function f of x equal ln of 1 plus k over x over 1 over x, and look for the limits when x goes to infinity. So we can do either way, okay? Symbolically is exactly the same, no worry, okay? So this will give me, so the limit will be, so we're going to take the derivative of the top, so it's ln of u, and therefore we have to use u prime over u. So we have 1 plus k over x prime over 1 plus k over x over the derivative of the bottom, which is minus 1 over x squared. So this is equal minus 1 over x squared, and then the top is 1 plus k over x, and the derivative is minus k over x squared. So be careful about the derivatives, huh? So that's the derivative of the top over derivative of the bottom. So we're looking at some algebra here. We have a fraction on the top time a fraction at the bottom, so it becomes minus k over x squared over 1 plus k, this is the top fraction, time minus x squared over 1. So this gives me minus time minus, that's plus. So we have k over x squared over 1 plus k over x time x squared. So k over x squared times x squared, we cancel the x squared, so we get k on the top over 1 plus k over x. So now we let x goes to infinity, and we find k over 1 plus 0, which is limit is k. So the limit of n ln of 1 plus k over n is going to be k when n goes to infinity. So now if I want to go back to my original one, so the limit of 1 plus k over n to the power n when n goes to infinity is going to be e of the limit that we just found, n ln of 1 plus k over n. So the answer is e to the power k. So you see here, depending on the value of k, you get different limits. So it shows you that 1 to the power infinity is not 1. So it can be different numbers depending on the value of k. If k is equal to 1, we find e, and if k is equal to minus 1, we will find e to the power minus 1.